Today, we are going to be talking about polynomials, something called linear factors, and also zeros. All this is going to connect us so that we can analyze and write functions. We're also going to be able to do some graphing today, and tomorrow and the next day. By way of review, we're going to do all our skills, everything we learned about quadratics, and apply it to the new stuff that we have today. So the first thing I asked you to do is to solve this equation by factoring. And if you recollect, all we do is snowy flaky. And I'm going to put a times c is negative 18. B goes on the bottom, and the 1x flanks it. Now from here, I find the two numbers that multiply, negative 6 and positive 3. So notice the instructions specifically say to use the zero product property. I know that you can get to the answer from here, but I'm going to show you the zero product property because today we're going to use it quite a bit. So I factored the left side to this. Then the zero product property says if two things multiply to be 0, then at least one of them has to be 0. So that means either of these are 0. So I solve for each one. X is positive 6 or negative 3. I put a ring around it when I am sure of my answer. I can always plug those in. Up here, 6 squared minus 18 again gives you 0. All right, the next part says to use a graphing calculator to graph the corresponding function. So after you graph it, we see here that I get a positive 6 right there. I get a negative 3 right here. And the vertex is approximately 1.5 and negative 20 point something. So it's about there. This is the sketch part. Now we just try to make a nice little curve that fits well. And it might not work the first time, might not work the second time, but we graph something like that. Next question says, how do the solutions here relate to what you graphed over there? Good. The solutions are the x-intercepts. Word to your grandmother's first cousin. Once we have our chart from our previous notes, well, clearly we see that we have a is even, and, the exponent is even, and the a is positive. So we know that this is going to be an up end behavior function. It starts from the up and goes to the up. And look, hey, what do you know? Up here and up here. Word up. Turns out that if we know the zeros of a function, then that can help us to factor it. That can help us to graph the function. That can help us to solve the equation that corresponds to it. All of that comes from just knowing our zeros. So that's going to be our key stuff today. So we're going to practice a little bit of solving. And let's refresh and just remember what we did here. Remember, after I factored, I split this up using what was called the zero product property. So we will get to that, but first we want to be able to factor. So let's recall, one of the first key things that we should try to do as we are factoring, and let me just refresh what factoring means. If I asked you to put 24 and do prime factorization, what would you do? Split this up, and I'm just going to choose two random numbers, 3 and 8. Am I done when I factor it? No, what else factors? Notice the 8 factors even further to a 2 and a 4, and even further to a 2 and a 2. So notice that sometimes the first step will yield me one of the results, but I might have to keep going. That's exactly what we're going to see here. I see that when I look at this cubic trinomial, I see that there is a common factor in all the terms. So notice that the common factor is 2x. So I'm going to factor out the 2x and effectively divide each term by 2x. So here I end up with x squared. Here I end up with 5x. And here I end up with a 6. So what was the reason that I did? Essentially what I factored out was the GCF. Now, just like we did with the 24, I factored out something, but there was another factor that can keep going. Oh, look, the trinomial there can be factored further. Now, what tool are we going to use to factor further? What tool have we been using for quadratics? I'm going to use my best friend, the snowflake. So I'm effectively ignoring this 2x right here. I'm just looking at the quadratic trinomial inside. And I put 6 on the top, 5 on the bottom. The wings are x's. I find two factors of 6 that sum to 5. That would be 2 and 3. So one of my factors is x plus 2. So I bring down this 2x. And then one of the factors is x plus 2. And the other factor is x plus 3. Box or circle it. I know I'm right because if I were to remultiply, I'll get back to the original problem. But what did I do here? First I did my GCF, if I could. I don't always have a GCF, but I factored out a GCF. And then I used Snowflake here to continue going if I could. It doesn't have to be this. Maybe GCF is the only thing I do and I'm done. Maybe Snowflake's the only thing I do. Maybe there's nothing I can do. Maybe besides Snowflake, I'm going to do special product, like a squared minus 9 or something like that. Pull out the x squared and then factor out of each term there. And we get x squared minus x minus 6. Now when you finish this up, you get x minus 3, x plus 2. And there we go. And now let's real quick look at the next one. I expect you to pause and for you to actually finish this one on your own. So go ahead and pause. Pause. We're pausing. I'm actually going to factor out a negative out. And generally that would be a nice thing to do, whatever the leading coefficient is. If it has a negative, go ahead and factor that out. We'll find it to be helpful in just a moment. So the leftover here, I'm going to take the opposite of each one of these, the opposite here, and opposite here. So I get negative 6x and positive 9. And now, some of you may notice that factor is a really nice one because you end up getting x minus 3 quantity squared. But just to show you by Snowflake, is I put 9, positive 9 on the top, negative 6 down below, x is on the wings. Negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 is negative 6. And so here are my factors. Notice I wrote it as a square right here because of the repeating there. Tomorrow we'll pick up and look at using this material for graphing and analyzing.